Dear students, today we're going to talk about the properties of solids, liquids, and gas. Let's start. What's the shape of this book? It has a rectangular prism shape. Does this shape change if I'll move this book from one place to another? For sure no. Let's discover the shape of these objects. A battery, a food can, and a mug have a cylindrical shape. A book, the bed, and this gift have a rectangular prism shape. An orange, a marble ball, and this lamp have a spherical shape. Accordingly, a solid has a definite shape which is fixed and never changes. Do you remember how to find the volume of a solid? In front of me, this regular shaped object. It's clear that it has a rectangular shape. I'm waiting for you to find its volume. Don't forget to start with the formula, then replace each term by its value, make your calculation, then write the unit. The volume of a rectangular shaped object is calculated by the formula V equal length times width times height. By replacing each term by its value, in place of length, I write 6 centimeters, width is replaced by 4 centimeters, and height is replaced by 5 centimeters. What is the operation shown in this formula? Multiplication. So, I'll multiply 6 by 4 by 5, and the answer is 120. What about the unit? As I've multiplied centimeter by itself for 3 times, the unit is cubic centimeters. Example 2. What is the volume of this irregular shaped object? What is the method used to find the volume of an irregular shaped object? The method of water displacement. What is the original volume of water? 150 milliliters. After adding the irregular shaped object, the volume increased till which volume? 180 milliliters. Great. Right now, take a minute to find the volume of this irregular shaped object and don't forget to show your work. The volume of the rock is equal to the volume with the object minus the original volume of water. Accordingly, it's 180 milliliters minus 150 milliliters. And then the volume of the rock is 30 milliliters, which is equivalent to 30 cubic centimeters. Do you think that the volume of this rock will increase if I'll put it in a bigger container? No. Thus, the volume of this rock is fixed. What's your conclusion about the shape and the volume of a solid? A solid has a definite shape and definite volume. How are particles arranged in a solid in order to have a definite shape and volume? Particles in a solid are strongly bound to one another, so they vibrate in place and not able to move freely. Accordingly, they are tightly packed and well organized. This rigid structure will give the solid a well-defined shape and volume. Let's describe the density of a solid. Already, we arranged that density is the mass of 1 cubic centimeter of an object. In 1 cubic centimeter of a solid, we have more particles because they are tightly packed and strongly attracted to one another. As we have more particles, there's more mass in 1 cubic centimeter. As mass in 1 cubic centimeter increases, the density increases. Accordingly, solids have the highest density. Already we know that kinetic energy is related to motion. As these particles are vibrating in place, there's less motion and then less kinetic energy. To sum up, solids have a definite shape and definite volume. Generally, they are the densest state of matter. Particles will vibrate in place because they are strongly bounded, and then they have the least kinetic energy. Let's discover liquids. What will happen to the shape of a liquid when it's moved from one container to another? The liquid will take the shape of the container. At the beginning, the liquid takes the shape of the bottle, then a cylindrical shape, and then a rectangular prism shape. Accordingly, liquids take the shape of their containers. What about the volume of liquids? In front of me, 200 milliliters of oil. If I move the same oil to a bigger container, will I have more volume? For sure no. The volume of a liquid is fixed. If I have 200 milliliters of oil, it will stay 200 milliliters. How to find the volume of a liquid? The volume of a liquid is measured by using a graduated cylinder. In front of me, 100 milliliters of water. Look how the shape of water changes according to the shape of the container. However, the volume stood fixed whatever if water is in a graduated cylinder, or in an Erlenmeyer, or in a beaker. How do particles in a liquid behave? The attractive force between particles is strong enough to hold them closer to each other, and then the volume stays fixed. This force isn't strong enough to prevent particles from sliding over each other, which gives liquids the ability to flow, and then they don't have a definite shape. As particles are a little bit far from each other compared to solid, there are fewer particles in 1 cubic centimeter, and then liquids have fractionally less density than solids. When the attractive force between particles in liquids is weaker than the attractive force in solids, the particles have a little bit more freedom to move, and then the kinetic energy is higher. More motion equals more kinetic energy. To sum up, liquids have a definite volume, but an indefinite shape. They take the shape of their containers. Liquid is the second densest state of matter. Particles are strongly bounded far enough to flow past each other, which lead to more motion and then more kinetic energy. Let's discover gases. In front of me, these balloons which are filled with gas. Look how the gas is taking the shape of the balloon. If the balloon has a heart shape, the gas inside will take a heart shape. Accordingly, gas will take the shape of the container. What about the volume of a gas? In front of me, these gas particles. Once they are released, they occupy the whole volume available. Let's discover the behavior of gases. Gas particles are extremely weakly attracted, so they move fast and far from one another. A gas particle will keep on moving until it hits the wall of the container, and therefore a gas will fill the whole volume of the container. When gas particles will hit the inner wall of the container, they create a force. This force is called pressure. When the pressure is so high, the container will explode. As these particles are so far from one another, we'll find the least number of particles in 1 cubic centimeter. Thus, the mass is the least. Accordingly, gases are the least dense state of matter. As the attraction force between particles is the weakest, particles are moving the fastest, and then motion is the greatest. Accordingly, the kinetic energy is the highest. More motion equals more kinetic energy. What will happen when particles absorb energy? In front of me, this ice cube. When particles absorb energy, they'll start moving faster. This energy will disturb the tight organization of particles in the solid. So, particles will slide past one another, and the physical state will turn into liquid. This process of transforming the physical state from solid to liquid is called melting. The temperature at which a solid will melt is called melting point. Give me examples of melting from your daily life. Chocolate, ice cream, and butter absorb energy, so particles will start moving faster and then will melt. Do these substances have the same melting point? The melting point of chocolate is 35 degrees Celsius, while the melting point of ice is 0 degrees Celsius. Accordingly, the chocolate needs more energy to melt. In the freezer, the temperature is so cold below zero. Outside, the ice particles will absorb energy from the environment. The temperature of ice rises till 0 degrees Celsius. Particles will get enough energy and start moving faster. The tight organization of molecules will be broken, and then the physical state will turn into liquid. What will happen to water when temperature keeps on increasing? The temperature of water will keep on increasing until reaching the boiling point, where particles absorb enough energy to move faster and far from one another. Then the physical state will turn into gas through a process called boiling. What's the difference between boiling and evaporation? During evaporation, only particles which are at the top surface will get enough energy to escape as gas. Although the temperature of the whole ocean didn't reach 100 degrees, particles which are in contact with the sunlight will escape. While during boiling, the whole quantity of water got enough energy to move faster and escape as a gas. Best examples of evaporation are the escape of water from seas and oceans during the water cycle and drying out the wet clothes. Best example of boiling is putting water on the oven to prepare tea. When water starts to boil, we'll see the gas escaping as bubbles from the whole liquid.